And of course, deleting data. There is a delete command, switching to OBX kites, just to walk through this sample. If we were to run this, and I'm not going to, it would delete every row from the OBX kites product table because there's no where clause there. So it's very important to remember. If you simply say delete from table, it's completely all gone. The only caveat there that might save you is if there are foreign key restraints that would prevent the delete. So typically when you want to delete, you're going to have a where clause and reference the primary key or some other way to say delete this particular row. Like the update command, there is the ability to have an additional from clause to define out a multiple table reference so you can then have the restriction or the where clause based upon a different table. And again, the ANSI standard would be to use this as a subquery inside the where clause, but T-SQL allows you to do the from. The confusing part here is we now have two from clauses in the delete. So the basic syntax of the delete is delete from table, and that from is optional, so it's normally left off. And then T-SQL comes by and Microsoft adds an additional from for this multiple table syntax. So it's actually delete from product, join product category. And I think that's sort of clumsy, but I wanted to point that out to you. So if I was to execute this, every product with a product category name of video in the product category table would then join back to the products, would be deleted from the product table. So all videos would be deleted. And while we're talking about deletes, it's useful to mention that referential integrity, the DRI version of referential integrity, meaning declarative referential integrity, in other words, a foreign key, can be defined so that it automatically cascades the deletes or deletes any secondary rows. When this happens, we call it the foreign key with a cascade delete. So in this example, and this is pulled from the create CHA script that generates the CHA database. This is already in the database. This is the event guide table, which serves as the associative table, also called the many-to-many junction table between event and guide. So there's a logical many-to-many relationship between events and guides, meaning that a single event could have many guides participating in that event, and a single guide could participate in multiple events. So it's a many-to-many relationship, and it's physically materialized within this table. Now it makes sense that if we delete an event, that any of these assignments of guide to event should also go away because it's meaningless to have those rows without the event there. And the same thing for guide. If we delete a guide row, we want to delete all of the event to guide rows that relate to that guide. So when we define the referential integrity here in that subtable, in the secondary table, we define that as a foreign key references and then say on delete cascade. So when we delete the primary row in the event, that this foreign key will also delete the secondary row here in event guide. And this is how you define the cascade delete. Okay, one last thing I want to show you on delete. A couple of times now I've mentioned this secondary from clause and how you can do it in an ANSI standard method using a where subquery. As an example of that, this is simply a sample saying if we deleted from table A, we could then restrict that to where exists something in table B, pulling out the reference using a correlated subquery, just so you see some sample code there for the ANSI standard. If you need to delete all the rows in a table, and the table is a large table, that might take quite a while because the delete command still functions as a transaction, and every row will be deleted through the transaction log. A workaround is a truncate table command, which bypasses the transaction log and simply goes to every data page for that table and marks the data page available. It's instant. But because the truncate table doesn't check all of the data, if there's even a foreign key that references that table as a primary key, the truncate table will not work. But but just another way to zap data very quickly.